Please see the description for timestamps. In this video, we're going to look at dilations that result in images that are smaller than the pre-image. These are called reductions, and they occur when your scale factor is between 0 and 1. Our first example is dilating triangle DEF by a scale factor of 1/2 with a center at 0, 0. Now it's easier just to take your coordinates, multiply them by your scale factor, and get your image coordinates if your center of dilation is at 0, 0. However, we are trying to broaden and deepen our understanding of dilations and performing dilations around any center of dilation, and so we're going to approach this problem a little differently. So what we want to do is start at our center of dilation, and let's just say we're going to focus on point D first. So from our center of dilation to point D, we're going to go up to left 8. So you could think about this as going up to left 8. You can think about it as a triangle. You could also think about it as a slope up 2 and then left 8. This is important because we know that our scale factor is 1/2, and so we want to reduce our slope reduce our fraction by 1/2. We want to reduce our slope triangle by 1/2. We want it half the size. So let's see what that would look like. So this is going to result in us going up 1 from our center of dilation and then left 4. So up 1, left 4. So D prime should be located at -4, 1. So notice that this slope triangle right here is half the size as the original slope triangle from the center up and over to your pre-image D. Let's use a similar strategy for figuring out the coordinates of E prime and F prime. So E has us starting at the center of dilation and rising 4. And so half of that would be rising 2. So E prime would be located at 0, 2. And then F has us going down 10, right 6. So down 10, right 6. We want that to be half the size, so we want to go down 5, right 3. So starting at the center of dilation, we go down 5, right 3, and we find that F prime is located at 3, -5. So after connecting your image coordinates correctly, we can see a few things about our dilation. One, we see that it was reduced, which is good because our scale factor was 1/2. We also can tell that our triangle DEF and triangle D prime, E prime, F prime are the same shape, just different sizes, and that triangle D prime, E prime, F prime, our image, is half the size as the pre-image, which is good. Another cool thing about dilations is that if you connect your pre-image and image, you're going to get a line that passes through the center of dilation. I do find this easier to do when you're using a ruler, but it's a really good way to make sure that you dilated around the correct point. Also, dilations are going to always have the orientation preserved, so the way you move around your points. So D to E to F is moving in a clockwise motion. So D prime, E prime, F prime should also be in clockwise, and it is. So that is another thing that reassures that we actually dilated correctly. Also, we know that triangle DEF is mapped onto triangle D prime, E prime, F prime by dilating by 2 about the origin, which means that side DE should be proportional to side D prime, E prime, and it is. D prime, E prime is half the size of DE. The same holds for side EF to side E prime, F prime, and side DF to side D prime, F prime. And so all of these things make us feel confident that we dilated correctly. Let's try one more example with a different center of of dilation. In this example, we're trying to dilate triangle DEF by 1/4 with a center at -2, -1. So you've already got that plotted. At first glance, I noticed that my intervals are different than usual, and intervals of your axes don't have to be the same, and they also don't have to be by 1s. So we do have to be mindful of that when we're performing transformations. So I'm looking at my center of dilation, and I'm trying to find how I go over to D. So it looks like I'm going up 2, right 3. So I know that for D prime, I'm going to want to go up 1/4 the amount and right 1/4 the amount. So I'm just going to write these as fractions, and I'm not going to reduce them either because I notice that my intervals are going by 1/4 every time, so 0.25. And so I think this is a little bit easier to leave it as fractions. So I know that I'm going to want to go up 2/4, right 3/4 from that center of dilation to find the coordinates of D prime. So we can see that D prime is located at negative 1.25, negative 0.5. Now let's figure out the coordinates of E prime. So we're going to go up 2, right 2, and then 5 more, so right 7. So E, we're going to go up 2, right 7. Because we're doing a scale factor of 1/4, we know that we're going to have to do a fourth of these measurements. So we're going to go up 2/4, right 7/4. So E prime is located at negative 0.25, negative 0.75. And now let's finish with F prime. So we can see that F, we're not rising any, and we're running to the right 7 units. So F prime, we're going to be going up 0/4, which is just 0, and we're going to the right 7/4 units. So F prime should be located at negative 0.25, negative 1. So again, I want to reinforce these ideas of dilations. We know that we performed a reduction by a scale factor of 1/4. So triangle DEF should be 4 times the size of triangle D prime, E prime, F prime. Other way of thinking about it is that triangle D prime, E prime, F prime is 1/4 the size of your pre-image. We can also see that the distances are proportional according to the scale factor. So side E prime, F prime is 1/4 the side of side EF. We can see that our triangles are the same shape, just a different size, again, according to the scale factor. We can see the orientation is maintained. So like D, F, E, we're moving counterclockwise. D prime, F prime, E prime, also counterclockwise. If we connect our pre-image and image points, they all pass through the center of dilation. Again, seriously use a ruler. I think that's really going to help you because you could force anything to look like it goes through, right? But they really genuinely are straight lines that all pass through the center of dilation. That's kind of the gist here. Don't forget, as you're doing these dilations, that you are starting at the center of dilation and going to your pre-image and then adjusting that according to the scale factor and then going back to the center. And then that's how you're going to find your image coordinates. And this will work for any scale factor around any point. And that's so powerful because in the past, we've just learned how to do it about the origin. And now you can literally dilate around any point there is.